Hello and welcome to the lecture on MOSFET metal contacts. In this lecture, we will see what material is used for as a metal contact. So this is a MOSFET structure. We have P substrate and see here we have P substrate and we have also P plus layer. This is highly doped layer. And be aware of this. This is N plus and this is N plus. These are highly doped layers and this P plus represents highly doped. So in the further you will understand why we are highly doping this P beneath the metal. Means the metal contact we are giving to the highly doped P layer. But for the sake of connecting to the metal contact, we need high doping here. But here we cannot use high doping. So it's a normally doped P substrate. And the same way beneath the contacts of these source and drain, there also we used highly doped N layer. So that we will see further how why it is so. So metal contacts, these are connected to highly doped concentration layers. This is to prevent the formation of Schottky barrier and to form a safer ohmic contact. As I explained just now, this is just to avoid Schottky barrier formation and to develop a good safer ohmic contact. Now, in the early days, aluminum was used as a metal contact, but later polysilicon is being used as a metal contact. So this is because of two reasons. That one is that for getting proper alignment during fabrication, we need uh, reduction in the parasitic capacitance. So because of parasitic capacitance, what is happening is that the switching speed is getting reduced. When we are using aluminum as a metal, the alignment is not proper during fabrication, resulting in parasitic capacitance, sorry, that is causing, uh, reduction in the switching speed. The second reason is that the doping process of MOSFET, it requires very high temperature like above 800 degrees Celsius. But aluminum will melt at 600 degrees Celsius temperature only, so we cannot use aluminum. Hence, polysilicon is feasible. Now, the polysilicon can be doped. So the polysilicon, it can be doped to tune its resistivity as desired. So we can tune the resistivity. Means if we want low resistance, we have to dope the polysilicon highly. Now, as we said prior, polysilicon, this gate will prevent the parasitic overlap input capacitance between gate drain CGD as well as parasitic capacitance between gate source or CGS. So this results in a aligned gate. Now, as the device with an aligned gate will be faster because the gate is 3 times smaller here. Hence, the high speed is possible with polysilicon, which wouldn't have been possible with a metal gate. So, the metal gate like aluminium. So, aluminium is a metal, whereas polysilicon is a semiconductor. Now, as metal as a gate material, it resulted in high threshold voltage compared to polysilicon gate material. So we know that to turn on the MOSFET device, we need to apply voltage above threshold voltage. But the threshold voltage with metal as the gate material, that metals like aluminum, the threshold voltage is high in that case. So with polysilicon, the threshold voltage is low. This is a advantage with polysilicon material. And the another good advantage is that the polysilicon, it is a semiconductor. So we know that for semiconductor, by varying the doping concentration, the work function can be tuned. Where that can be work function can be varied. But whereas for metals, the work function is constant. So and polysilicon material, it is cheaper than the metals, and the number of steps involved in fabrication with polysilicon is lesser compared to the metal. So, so these are the things about uh, MOSFET contact materials between aluminum metal and polysilicon. Thanks for watching this video and please subscribe my channel to get